Morning, guys. So this video is for beginners to mechanics. If you are in class 11th and you are new to Newton's law, you will find this interesting. If you're an advanced level learner, this video is not for you, so you can drop off, right? Okay, let me show you how to find the resultant of forces acting on an object. So a lot of beginners I teach, have this problem that they are not able to understand the application of Newton's second law because the underlying reason is the lack of knowledge of vectors. Okay, so if you don't understand vectors, it actually becomes very difficult for you to solve the questions pertaining to resultant. Okay, so if you understand vectors, it's easy for you to find the net force. You will find a lot of questions on Newton's second law where there is a block and there are multiple forces. You're supposed to find the acceleration. You're supposed to find the direction of the acceleration. You're also supposed to find the net force. How do you handle all of this? It's very simple, and it comes from your knowledge of vectors. Okay, I will solve each one of these, and hopefully this will strengthen your concept. Or if you're still struggling, you can watch other videos. Let me start with the first one. Okay, so if you notice, the first block, okay, is being acted upon by a 12 Newton force, and the other one is 18 newtons. Both are on the right hand side. So if you think it from vector perspective, these are x and this is y, right? Both are positive x-axis. Okay, so I can add them vectorially. Okay, so the F net, okay, what we're learning here is vector addition. Force is a vector, and vector addition means adding two forces or more forces with the help of vector algebra. Okay, since the direction is same, I can write this as 12 plus 18 is equal to 30 newtons. Okay, if the mass of the block was say 6 kgs, the acceleration of the block will be 30 divided by 6 is equal to 5 meter per second square in the direction of the force. So if the force is rightwards, both the forces are rightwards as per the sign convention of vector algebra. If the forces are in the same direction, you add them like numbers, but you also write rightwards. Okay, acceleration is 5 meter per second square, right? No brainer. Let's come to the problem number C. Okay, if you see the problem number C, whatever is going to happen to this block C is going to be because of two forces, 12 newtons and 4 newtons. Okay, now look into the direction. Okay, we are doing vector addition, and in vectors the direction is very important. The force number one, okay, let's say this is force number one, wants to pull it on the left, right? So I'm going to write it as minus 12 newtons. Reason? Sign convention. If anything is on the x-axis, towards the positive x-axis it's plus, towards the negative x-axis it is minus. Okay, so you can see it is on the left hand side, and therefore this is minus 12 newtons. And on the left, then let's talk about the right. Okay, so the negative sign tells you about direction. The rightward force is plus 4 newtons. Okay, I am emphasizing plus 4 to tell you it's right, and this is left. Now let's add and find the net. Okay, I'm writing this arrow represents that this physical quantity force is a vector, and I'm going to write this as the sum of the leftward force plus sum and the rightward force. These are the two forces which are getting added. So minus 12 plus 4 is equal to minus 8 newtons, which means the minus 8 is a net force which is in the leftward direction. Okay, so the body will move leftward, and if, for example, the mass of the body is again 6 kgs, the acceleration is going to be minus 8 upon 6 is equal to minus 4 by 3 meter per second square. So A and C, I hope you can see the difference. This is both rightwards. This is one leftward, one rightward, and you're using vector algebra. Okay, vectors don't get added like numbers. You don't write, you know, the answer to this as 12 plus 4. These are not the numbers. You have to see the direction, leftwards and rightwards, opposite to each other, and therefore this minus sign. Let's move to the next one. Okay, let's do D. I will do B and F and E together, but since A, C, and D are horizontal forces, I hope you know this. This is horizontal force, and a force which is up and down is a vertical force. Let's go to D. Okay, let's look into D. So what are the external forces acting on D? There is a force which is 10 Newton. Then there is another force which is 10 Newton. And then of course there is a force which is in opposite direction, which is 5 newtons. And now if you want to find out F net, how do you do that? You have two forces on the right hand side. Okay, so I'm adding them like numbers because they're on the same direction. And then I'm adding a minus 5 force, minus because it is leftward. So my net force is 15 newtons. And therefore, this is called as the net force, the resultant of all three. The impact made by all these three on this block. So if this block is again 6 kgs, I'm going to write acceleration is going to be 15, which is the net force divided by the mass of the body, which is okay, is equal to 2.5 meter per second square. Okay, I hope you get this. How do you add and subtract? This is pure sign convention and vector algebra being followed. The only way to learn mechanics or this chapter is to be strong in vectors. A lot of problems will get easy. You can watch my playlist on vectors for physics. Thank you. All right, let's move to the next one, which is B. All right, now B has a mix of horizontal and vertical. Okay, so we will put two boxes, X. In the X, the only force is 6 newtons. So it is plus because it is rightward. And look at Y. So on the Y axis, you have one force which is 8. Upward force is positive. The downward force is negative. So let's see what happens. If I do the totaling of X axis, it is only 6. If I do totaling on the Y axis, it is 0. Therefore, the only force acting on this block is a rightward force of 6 Newton because 8 and 8 cancelled each other, right? So the resultant is 6 Newton, and if your mass is again 6 kgs, you will get your acceleration to be 6 Newton upon 6, and you will write it as 1 meter per second square rightward, right? So this 8 Newton and this 8 Newton cancels each other. External forces, like a tug of a war, they cancel each other, and the net resultant direction is going to be rightward. Let's move to the question number E. Okay, let's see this. If I were to see E, I see two forces, both vertical, both downward, and therefore the net resultant force. Downward force is a negative, so minus 4, and then minus 6 is another one, right? So this is going to be minus 10 Newton, and therefore the acceleration is going to be minus 10 upon 6 is equal to minus 5 by 3 meter per second square. Make sense? All right, let's go to F. If you see F, I'm going to write all the external forces on this particular block. One force in Y upwards is plus 26, and then there's a downward force which is minus 6. Okay, so this is the total of the upward force and the downward force is 20 Newton, and it is in Y axis. So I write F resultant Y axis. It is plus, so it is upward. So this body is going to go up with an acceleration of 20. Let's say the mass is 6 upon 13 by 2 tens are and 2 threes are, right? So you get 3.33 meter per second square. So the idea is if you understand vectors and you understand sign convention, it's it's a cakewalk. It's not difficult. So Newton's second law, you must know how to apply F is equal to ma, and F is made up of multiple components which are horizontal, vertical, and each component has to be given a positive and a negative sign to decide how much contribution it will make to the resultant. So I hope this made sense to you. Please go through this video, and I have some 150 plus videos on mechanics and around 2000 videos. You will find them useful. Please try and watch them if you can. And thank you very much for your time today.